In this section we're going to look at radical functions or root functions, and we're going to look at a couple of important graphs: f of x equals square root of x and g of x equals cube root of x. Also keep in mind another way to write this is x to the half, now that we know rational or fractional root exponents, and then g of x is x to the 1/3. So these guys are the same. Be used to both ways of writing them. We want to make sure we remember and know how to evaluate functions, which is basically just plug in the input. So for example, if I have f of x equals square root of x and I want to evaluate, let's say, f of 4, well then that's just the input as we would do before. Put it in the square root function and that's going to pop out a 2, so that would be a 4, 2 on the graph. The ordered pair would be 4, 2. Or if, let's say, I said evaluate f of -9, for example, you would put -9 and then you would realize, well, you can't do this because right now it's a negative under the radical, so you would say either undefined or not real, and the input would not be on the graph at all, so not on graph at all. In other words, -9 is not going to be on the graph of this square root function because the input did not produce an output. Let's say I had to evaluate g of 8 for this cube root function. Of course I would put in the 8 and then cube root of 8 would pop out a 2, so 8, 2 would be on the graph of this g of x function. Or if I said evaluate, let's say, g of -64, you would put a -64 in and that would pop out a -4. So negative under a cube root is going to be okay. We can actually evaluate that because that's -4 times -4 times -4. So then we would have -64 and -4 on the graph of the cube root function. So let's graph the square root function. I'm putting in some inputs, some x's that I picked, and I'm getting some outputs for the y's. Now if I try to take square root of -4, we can't, so that's going to be undefined or not real. Same thing for that, that's going to be not real. Same thing for -1, that's also going to be not real. And then the minute I get to 0, square root of 0 is 0, so that's okay. When I input the 1, square root of 1 is 1. When I input the 2, square root of 2 is 1.4. So again, you're going to use your calculator to approximate some of these. Then square root of 3 is going to be approximately 1.7. And then square root of 4, that pops out a nice 2, we know that. Square root of 5 is going to be approximately 2.2-ish, and then square root of 9 we know is going to be 3. So we have some ordered pairs that I'm going to go ahead and graph. I have 0, 0, 1, 1, 2 and 1.4-ish, 3 and 1.7-ish, 4 and exactly 2, 5 and 2.2-ish, and then we have, there we go, 9, and at 9 I'm jumping up to 3. So notice if I connect the dots, it looks like it's going to be curvy, and it's going to keep going and rising up to the right. Now let's analyze the graph a little bit more. Let's try to get the domain and range of this graph. Notice the domain is all the x values that give me a valid output for the function, and I walk left to right. It looks like it starts right here at x equals 0, including 0, if I put it in interval notation, and then I keep going to the right forever, so all the way to infinity. In other words, x is greater or equal to 0 if I want to put it in set notation. So this is interval notation, and this would be set notation. Same thing for the range. I'm going to be walking from the bottom all the way up and up and up and pick up all the y values. In the first place I hit the y values right here at the origin, which is a y value of 0. And then it keeps going up and up and up. Not only does it go to the right, but it keeps going up and up and up slowly, so the y values keep getting bigger and go to infinity, or in set notation y such that y is greater or equal to 0. So we got the domain and the range of the function as well. Let's graph the cube root function. So g of x equals cube root of x. I'm going to put cube root of -8. The input is a -8, and that's going to give me a -2. Cube root of -4, I'm going to have to approximate. And that's going to be about -1.6, so I use the calculator and we approximate it. Same thing for cube root of -2, we're going to approximate that, which is going to be about -1.3. Then we get the cube root of -1, which we know is -1. Cube root of 0 is 0. Cube root of 1 is 1. Cube root of +2 is back up to here, approximately a +1.3. Cube root of +4, just like this one, approximately 1.6. And cube root of 8 we know is 2. So notice you have negative x's and negative y's, positive x's and positive y's. Now let's go graph it over here. I have -8, -2, -4, -1.6-ish, -2, -1.3-ish, -1, -1, 0, 0, 1, 1, 2, 1.3-ish, 4, 1.6-ish, and then 8 back up to 2. So I have a curve on this side that gives me negative x and y values, and the piece of curve on this side that gives me positive x and y values. Notice here I had nothing in these quadrants, only in quadrant 1, because these were all no good. But here negatives are good and positives are good. So the domain is going to be, if I'm walking left to right, I come all the way from the left and I keep going and going to the right. So it's really -infinity to +infinity, which is all real numbers. Same thing for the range. If I try to walk from the bottom and go all the way up, notice this piece keeps going lower and lower, and this piece keeps going higher and higher. So I happen to have the same range, small, very small negative y values and very big y values as I go to the right, so the range is also all real numbers.